Hi everyone, let's discuss this question which recently came in the LeetCode weekly contest. So, this question we have to find the punishment number of a given number n. So, what is a punishment number? It is defined as the sum of all the square of integers I such that the decimal representation of uh, I square can be partitioned into contiguous substring such that the sum of the integers values of those substrings equals I and that the I starts from 1 to n. Okay, so let's understand this highlighted statement. So suppose we are given a number 1 2 3 4. In how many ways can we partition it here and partition it? So what will be it? 1 plus 2 plus 3 plus 4, 23 plus 4, that is 528. Again, you can also partition it like this. Then what will be it? 1 plus 2 plus 3 plus 4, that is 10. So these are the possible ways. Now, the first thing that comes to our mind is that how do we find the total number of partitions. So let me tell you what at max how many times can we partition a given string. Say 1 2 3 4. Again we take that. How many times can we partition? So let's say we partition it here, we partition it here, we partition it here, we partition it here. So there are four partition endpoints, right? So total how many there can be partition points? You can either take it or not take it. You can either take it or not take it. You can either take it or not take it. You can either take it or not take it. That is 2 into 2 into 2 into 2, right? That is 16 partition endpoints. That's what we have. So why don't we represent those 16 points in the form of bits? Say 0 1 2 3 4 5 6 7 8. Let's do till 8 only. So what will be it? 0 0 0 0. It will be 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 1 1 0 0 0. Okay, let's start it. So we have the number 1 2 3 4. So is there any partition here? No. So we'll directly add this whole number to our sum. So our sum becomes 1 2 3 4. Now we are gonna check if this is equals to 8, what we are getting as input. We will check that in defined function. Okay, now in this case it will be 1 2 3 4. So our partition ends here, means sum will be 1 2 3 plus we get a 4, and it stays somewhere where we store those substrings. Okay, so after the string is totally traversed, we put that 4 also. Thus it will be 127. Now again that's 1 2 3 4. So this will be, so a partition ends at 3. This means sum equals to, okay, sorry, I did a mistake. Last one, our partition ended at fourth position, right? So it will be again 1 2 3 4. Now in this case our partition ends at 3, so 1 2 3 plus 4, that is 127. Okay, now again 1 2 3 4. So our partition at this position means 3, and the partition ends at 4. Okay, so what will be the sum? 1 2 3 plus 4. Okay, is 127 again. Now 1 2 3 4. Now we are in this part. Okay, so our partition ends at first position or second position. Said at first is a zero based indexing, so partition ends here, means sum is 1 2 plus 3 4. Okay, means 34 plus 46. Okay, 1 2 3 4 again. Now we're in this part, so a partition ends here and a partition ends here, so sum is 1 2 plus 3 4 again, the same one. So okay, now 1 2 3 4. So we are here, means a partition ends here and a partition ends here. So what's the sum? Let's see this. Will be 1 plus, oh, sorry, 12 plus 3 plus 4, right? Partition ends there, means 12, and again the partition ends there, means 3. Now we have traversed the whole string, we were left with 4, so we add that to that sum. So this is 19. Okay, 1 2 3 4. So now there are three partitions, I mean this ones. Okay, the partition here, partition here, partition here, so sum is 12 plus 3 plus 4 again, that is 19. And in this case, this one partition ends here only, so sum is 1 plus 234, that is 235, isn't it? In this way we can check all for all the partitions what's the sum, and if in any case the sum of the sum is equals to n. So let's say we are given included the function n, and while checking through all these partitions, if anywhere, if excuse me, if sum equals to n, we will do this for n square, right? Like we do this for all n square. If sum is equals to n, then return 1, else return 0 at the end. Let's understand this was code. So we have iterated from 1 to n. Okay, and we have checked in the function if it exists, then we have added I into I. Okay, now here we have found n square. Okay, and converted that into the string. Okay, now there are uh, like 2 to the power length of the string possibilities. Okay, now this is the sum variable, and this is the string t, where will we store the contiguous substrings. Okay, so first of all we put a character in the string, and then we check if that position is set in the bit, that means that there are partition ends, so we directly add that, that substring after converting it into a integer, then add it to the sum and make the string empty again, right? And and right at the end, suppose like say in this part, at the end 4 was left in t, 4 will be left in t, right? You can check it like here. Here t will be equals to 4 right at the end. So like for this example only I'm saying, now if sum is equals to n, mind it, I did this for the string n square. Check, I converted n square into a string and did all the operations, and check if the sum is equals to n, then return 1, else we will return 0. Okay, so let's discuss the time complexity now. So we are traversing here from 1 to n, so there will be, excuse me, O of n into O of this this check function. Okay, this check function or the total number of operations, this is 2 to the power d. Let's call this d is the number of digits in the yes, number of digits in the number n square. Okay, into d. Okay, d equals to number of digits in n square. Okay, now d can be at max what? D, what can it be? So we are given n can be at max 10 to the power 3 from 1. Okay, so n square will be 10 to the power 6. So how many digits are there in 10 to the power 6? 7, right? So this will be 1 to 7. So the time complexity will be O of n into 2 to the power 7 into 7. So we can consider it as a constant only. So it will be more or less O of n. Okay, I hope we are clear with the solution. Please comment down in the comment section if you are not able to understand anything.